Okay. Hello everyone. Good morning. Um, how about the air conditioner? It's ready. Okay. It's ready. Okay. Okay. Uh, Before we start, uh, because I forgot to show you the uh, this schedule. Okay. So this is our schedule. Um, So basically, in September, we will doing all the chapter one review. Basically, that's the high school mathematics um, introduction of limit, and then there is no class this afternoon. Your TA class will be on 25. Um, I think the TA will come to today, but I will let you know. And then um, on October, we will start to go details on derivatives. And November, we will go for the integral area between curves, volumes, and still volumes on December until the improper integral, and we will have our chapter 8 as our last chapter, arc length and surface area. And then some review on Friday DA class, and hopefully exam before the end of the year. Okay, so this is one possibility of exam. If we need to take more time to get all the information we need, then we have two possibilities. Either it will be this January 4th or 11th. So all depends on our progress, whether we will be quick or slow. Okay, so I will inform you if we have a quiz. So I plan quiz end of this month, but I'm not sure. Maybe in October. Okay, I can move this um, because I'm planning to have on September. We will take the class really slow, okay? And October then we move faster because several students still not in the class. So my focus divided by you and the online students. And then the midterm is in November, this 9 November. If not, then 16. This is possibility also. Okay, and I can move another subject to other day, to 9 or 16. It depends also on our progress. Okay, so that's about the our schedule. I will upload later this into the Moodle system, so don't worry. So we will start actually with the function. So wait. Okay. So can you read all? I will try to write bigger. So I've told you before that calculus, okay, calculus, it has two main idea. Okay? So derivative and integration. And both this main idea is basically established from this from, let's say, similar concept of infinitely small. Okay, and before we going deep into the calculus, uh, the basic lessons. Okay, so in math, you have at least learned the function, right? The algebra, geometry. At least these three are essential for our calculus. Okay. So I want to know whether you guys take the math test, right? The test for math. Who passed the test? 1, 2, 3. Okay, good. Okay. So I want to ask, why do you fail? Why you're failing? Or is it difficult, the questions? Or the questions, you have seen the questions before, but you forget to solve the questions? Which one? Is it difficult, or you forget how to solve it? Who think the questions is too difficult? Yeah, it's okay. You can, if you think these questions for the math test is too difficult, just raise your hand. Or do you forget how to solve the problem? Most of you think that you forget. Okay, then I can make a simple conclusion that what you learned before in math, basically just memorization. You memorize formula. Okay, formula for triangle is blah blah blah. Geometry for this blah blah blah, and then you apply for questions in exam. Oh, I can do it, and then you get maybe score. Okay, so when you approach subject like math like that, okay, of course in time you will forget. You will forget the formula. But if you know why the formula apply like that, then you will, oh, maybe I can do it better. So why I want to approach is, do not take math just memorize things, memorize formula, memorize how to solve problem. It will not help you in the future. Math, it actually help you think logic, critical thinking, see the pattern, um, modeling the situations you're in. Like we are in a situation of the pandemic, the coronavirus, right? How to model that virus, how to model the exponential of the virus in some area. That's need math also. Okay, so that's one thing. Okay, so for now, I want to make some tests. Okay, okay. The first question. Okay, um, determine the domain of the function. Okay, try number one first. Remember domain? No? Yes? It's from the basic uh, functions. Okay. So every function has domain. Okay. And also range. Domain, range. Okay. Probably you have seen this before. So this is A, this is B, you have this, and you have, oh, arrow here. Which one is domain, A or B? Yeah, A or B. Which one is the domain, left or right? A or B? Yeah, who's A? Who's A? Okay, A, okay, okay, okay. Okay, so you remember that is the domain, okay? But how to apply in the functions like this? How to determine the domain? Okay, so the functions, any functions you see in math equations, imagine that is like a machine. When you put something in that machine, either that is the fuel or anything, it should be make sense, right? Everything should be make sense. Your A should be make sense when you are putting into the function. So every x that you put into this f of x, every x should be make sense. That's the first thing. Should be logical, make sense in math world. Okay. So then, uh, basically, every functions, you can say most of the functions, it has real numbers as domain. So all real numbers is the domain. But there's a few exceptions. Okay. So you can say, oh, maybe all x, we can put it. Can you put all x into the equation? No, right? Okay, so we need to make that exceptions. So first, this A, this B. Number A, what is the domain? Can it be negative? Why? This is 3. Okay, 3, not 2. Can it be negative? Here? Negative here. It's 3. Okay. Negative 1, negative 1, negative 1, negative 1, right? Okay, so negative can, right? How about 0? 0 here, 0 here. No problem. Okay, right? So can I say this all real number or no? Yes, right? Still confused? So mathematics makes you think, ponder, but you need to decide, right? Math helps you decide. So if you not having any disagreement with anything, then do it. So there's nothing wrong with this. So we just say that the domain is all real number, or we can say from negative infinity to positive infinity. So all, or we can say this is all real number. So x element of real number. Okay. But the second one, it has square root something. Okay. So we have square root of 4 minus x plus square root of x squared minus 1. So first, okay, we need to make some rules, okay? So if you have seen this square root, okay, if you want to make a real number, so you need to make it greater than 0, right? So everything here should be greater than 0. Can it be 0? It's okay to 0? Okay, right? So there. So that's true, okay? So you can do it one by one here and here. Okay. So 4 minus x, you can have 4, right? And x squared, you can have also 1. So I can write this as from negative infinity until negative 1. And negative 1 is included because it's making 0 to the square root. And from 1 to 4. About 0? 0 is also 0 is making negative, right? No, right? How about 0? If you plug in 0 here, no, right? Okay. Got it? Got it? Okay. If the number is simple enough, you can try, like, maybe how about the fractions? Like half is also negative, right? So you cannot do it, right? Okay. So I will make some from what I've done before, and I've experienced in the rational functions. Every time you see okay, there are 3 conditions at least that you might tackle and maybe having a problem. So first is this one: any function over any function, square root something, log something. So this is to help you make a decisions. So this is can it be 0? No, right? Okay. So what should I write? I can write this is not a 0. And how about this? X should be 0, right? And how about log? Log 0. Is there any log 0? You're discussing. Okay. No, right? No, right? Yeah. This log cannot be negative, right? Right? You can check the log graph. Log 1 is what? 0, right? Log 10, 1, 102, 1003. Okay, right? Why do you think we need to establish log? Why do we need log? Because sometimes when you are doing some maybe experiments or see any data, if the data multiplying in like really big number, it's easier to make it log. So you can make it simple graph and make conclusion from it. Like millions, 100 millions, it's easier to log, right? Make it log in log scale. Okay. I have another question to make sure that you have um, idea of functions. So I have too small. Make it bigger. Let's say I have this. Okay, this fx. Okay. Okay. Let's say this is y equal f of x. I want to know the graph of y equal negative f x. Try to sketch and remember how the graph will looks like. You don't need to draw really in good scale as long as it is logical to do. You can do it. So you have the functions here. Okay, it can be any functions, but instead of the curve, I have a straight line so that it will be easier to understand. So I have these functions. It has negative. Will the functions go here, A or B? Negative. A or B? B. Who's A? No, who's B? Okay, good. How about you have y to f of x minus 1. What does minus 1 mean? It's going up or down? Up or down? Down, right? Okay, good. So plus will be up, right? Okay. How about in here you have negative 3? Left or right? Right. Okay, good. Okay, I'm just checking. So you have pretty much most of you good understanding of transformation of functions. Okay, so don't forget it. Okay, if you forget, you can just go to any graphing calculator, any website that has graph calculator. Try to just make some simple functions, maybe x squared or straight line, and then play with the graph. Okay, you can plus, you can minus, you can actually make it twice. If you have this twice, what does it mean? Yes, correct. Okay, so the slope will be more vertical, right? Okay, good. Okay, so I can a little bit going into the functions and go through the calculus. Okay, so I'm taking slow because I want to make sure all of you have um, good grasp of basic of math. So functions. This is just for your information. Okay. So I think it's better if you understand the function through this visual. So if this is f of x, this is x-axis, y-axis. Okay, so this part is domain. This part is range. Actually, there are some definition, but I don't think that you need to remember. What you need to know is if f is a function with domain D, yeah, uh, pretty much this domain means any possibility of x. Okay. And range is all possibility value of f of x. I'll make it bigger. Um, every chapter's finished, I will upload that chapter. Yeah, the PDF one. Okay, I think this is quite intuitive. You don't need to remember. As long as you know the logic of domain and range, you'll be fine. Okay, you know the logic of domain, you will also understand the logic of range. Okay, so range will be depends on domain. So if you need to determine the range, you need to determine the domain first. Then you can determine the range. Okay, how to represent functions? How to represent functions? Okay, first you can do it by words. Like usually in textbook, there are a lot of theorem. If blah blah blah, only if blah blah blah. Maybe you have heard before. I don't really like to memorize that word, but that is words first. Second, it's numeric in numerical. Usually it has a table. Okay, so you have x, you have f of x, and you have the number and then the functions. You can also do that for representing the functions. Okay, and three, you have a visual. This is graph. Okay, I think mostly you can do the algebra. This is the formal definition with mathematical symbol notations. Okay, we call it the algebra. By the way, I always say that in the first class that what is algebra? Anyone know? Maybe in someone in basic math know. Okay, algebra is literally, it's not just like operating. It's operating a system. Like you have equation equal what x plus 2 equal what, and you need to solve the x. That's algebra also. Or x squared plus what quadratic functions. That's also, we call it algebra operations. But algebra means, at the very first introduction, in Arabic, algebra means to fix a broken things. So meaning it's actually modeled to solve any mathematical problem and make it in balance with with equations. Okay, so at the first time it takes form to solve modeling equation in it for a math. Okay. Okay. Okay, I think we can move on. Uh, even and odd functions. Okay. Anyone heard before? Even and odd functions. You've heard before? Okay. So even, for example, x squared. We call x squared is even. We call x cube is odd. And do you know what's the difference? between even and odd. Why we need to make difference in even and odd? Not really, not really. Do you know the graph of x squared? It's the most, I think, most elementary student learn, right? Yeah, when you learn the quadratic elementary, right? You learn quadratic in elementary, right? Yeah. So here's the x squared. Okay. How about the x cubed? The same or it's going to negative, right? So and it has the, we call this the inflection point, but we learn that later. Okay, so from the graph, we call this is a symmetric, right? Symmetric because it has the same, right? And this is asymmetric. Okay, of course it's because it's not symmetrical. So it's going negative here, and this is positive one. So the easy way to remember, if we put negative here, it will always be positive, right? So that is just the difference. Okay. So if you put f of negative x, if it's fx, then this is even. And for odd, if you put negative x inside, it will be negative f of x. Symmetrical or not symmetrical will be, I think, a little bit important later in integrations, and maybe before that, this when you sketch the graph also. But that's for later day. Is it too slow or just okay? Okay. If you feel too slow, just okay. And the other thing, have you saw this before? Okay. If you have these functions, okay, you have actually two functions, right? Inside this one, it's actually one function, but it has two behavior. One is this, okay, and the other is this. Okay, it has two characteristic, two different graph. We call this by piecewise defined function. So depends on the interval. So if I say, if I want to make or plug in -2, so you need to use the first part. But if I want to measure 0, use the second part, right? Okay, and then you should be able to draw this sketch. Just a rough sketch is that still okay. X squared here, okay, is x squared, and around here, this will be, yeah, yeah. You will see this kind of graph later on when we are dealing with limit, okay, because there's interesting part here because it has like a gap here. In calculus, we call that the discontinuity. Okay, you have functions continue. Maybe you have heard before continue. Continue means You draw a graph, you do not like pick up your pencil or pen. You draw all the graph. That means it's continuing. But if you have pick your pencil or pen and make a graph, it's not continue. It has some hole. Okay. Maybe it jump. Maybe it's just remove the 1 point. It's still discontinued. But sometimes if you use a graphing calculator, you know that there is one hole, but in graphing calculator, usually just draw, which means it actually has a hole, but it has a limit. So yeah, I will tell to you later. That's the important thing of limit. Okay. Another part. This is some essential functions. If you forget, you can try to maybe sketch some, and I think you should be able to draw by taking some simple number by yourself. Especially the 1/x, the log, and trigonometry. This is important. Also, we have done this before, the questions. So this is the translation for the functions. So if you have plus constant going up, going down, if you have the x minus going right, plus going left, okay? And then if you have multiply by constant, means the gradient will be changed, the slope will be changed. And if you have negative, it will be reflecting through x-axis. If you have the x negative, it will be going to the left here, reflecting to the y. Okay. Anyone remember the f, o, g, g, o, f? If you have f of x, you have g of x. Remember this? These two? Okay. So this is just review a little bit. Make sure you have learned before. Okay. You plug in the function into the other functions. It's called the composite or combination. Oh no, just composite. Yeah, this is the term. Composite function. What else? Okay, anyone remember the F inverse? The inverse. Remember? Let's try. Can you still remember? Solve the inverse. Anyone remember how to inverse? Okay, before we're going to solve, what is inverse? Okay, so you have domain, you have range. Okay, you have domain, you have range. So inverse means the range becomes domain, the domain becomes range. Okay, that's the inverse. And the other thing is the functions should be 1, 2, 1 function. What is that means? So here, if of A, B, this is 1-to-1 function. Okay. If you have, for example, that's not one-to-one. Okay? Because 2x going to 1fx. That's not one-to-one. Okay? So inverse can be done if it is one-to-one function. Okay? So how to solve the inverse? I prefer, okay, I prefer to make it into y x cubed plus 2. And then I solve the x cubed. And then here, make the square root of cube. And then switch x and y. So you have y. And this y is the f inverse. So this is the f inverse. So f inverse is okay. So basically what we are doing is we are switching the domain and range in this solution, switching the domain and range. Okay. Okay. Okay, that's a review from really chapter 1. I'm not going into all the chapter 1 because I think most of you already have basic knowledge of that. So we can um, continue to the other chapters. Okay. Okay, any questions before? Any questions? Or you have any requests? Maybe which sections in high school you need review? But I think like the basic, really basic foundation of calculus you have learned before, but probably you don't know why you learned it before. Okay. Okay. Um, let's try this one. Okay. I'm started with this is y equal x squared. Just a simple x squared quadratic function. Um, there's a question. Find equation of a tangent line of the parabola y equal x squared at let's say point P 1 1, which means here. This is P 1 1. Okay, just pretend you are not knowing any calculus, any derivative, any tangent situations. Okay, so you need to find equation of tangent line. Okay, if you don't know any limit, any derivatives, okay, pretty much this is what you are well doing. Okay, so you have, let's say another point here, q. Let's say just say this is x and x squared, according to the functions, right? Let's say you have this p and q. Okay, if I draw line, or maybe with red, if I draw a line like that, I know at least this, from this triangle, I know the tangent, right? I know the tangent. The tangent or the gradient of PQ is the x squared minus 1, x minus 1. Or if you want to remember the whole equation, this, right? Or sometimes it's A, B, but I think you get the point. This straight linear equations. Okay. And To understand the concept of limit and how it relates to the tangent, okay? So imagine this Q, okay? Imagine this Q point here, okay? This Q point will be moving, okay, through here, 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 because what you want to know is the tangent, okay? By the way, why it is the gradient? It's called tangent. Why? Do you know why? Why it's called tangent? Have you thought before, or you just learn, oh, tangent is just y over x? Why it's called tangent? Tangent means it's tangible. You know tangible mean? Tangible means at this one point, it barely touch one point, tangible at that point. So that's why it's called tangent. Okay. So every time you heard tangent, which means at exactly one point, it's touching there. Okay. So if I try to draw here, maybe the tangent is something here. Yeah, maybe like that, the tangent. Touching the one point exactly. Okay. So the idea how to get to the tangent is moving this Q, moving to P. Okay. So you can choose any X. So this is start 1, right? We need to get closer 1 from Q. Let's say Q is from let's say 1.1. Okay, and we calculate the gradient. The M PQ is 2.1. Okay, and we getting closer. Let's try 1.01. Okay, we get here. And when you get all the way closer to 1, but it's not 1 yet. It's not 1 yet. It will be 2.000 more 0 to come, right? And another point I want to make here is R here, left side of P. Okay, let's say the R is getting closer. So let's try X from 0 and also make the gradient from R to P. Try to make gradient there. And then we get RP, the gradient RP is 1. Try 0.9. It's closer to 1, right? It's around 1, yeah, around 1.9. And getting closer, 9, 9. And more 9, it will be 1.9999999, a lot of 9. Okay. So that part, okay, this the gradient PQ and RP is actually getting closer to finite number 2, right? This is 2.0000001, and that point 1.99999. Okay. So the idea of getting closer and closer to some finite number, that is limit. Okay. So when Newton, okay, he may be sleeping and apple falling down, he thought that why the apple goes down, but why the moon is not going down? That's the question Newton asked. And then he tried to doing some research, and he find when the object, like a ball, he dropped the ball is getting faster. There is something in when he dropped the ball. Okay, and then uh, he find this graph. Let's say this is the force, this is distance. Actually, it should be from left to right, but I'm switching. It's the same. So Newton wants to know, after a few seconds, he wants to know the exact velocity, because the velocity is changing from dropping the ball, because there's accelerations, right, from the gravitational force. Okay. So he make this graph, and what Newton do? Okay, this is what he do, like we've done at the previous slides. So we put some point here. We put some point here. Let's say this is A, this is B, and we have the line. And then he cut all through line, like we did before. He cut, and getting this A and B, getting closer in one point. We can try from A getting closer to B, or B getting closer to A. It's the same. So that is what Newton did. So let's try to have so let's say this is x. Okay, this is x plus h. This is h. So this is f of x. That means in A, this is f of x, because there's no other subject there. And B, because it's changing plus h, it's changed to x plus h. Okay. The gradient, okay, meaning here, the gradient is this part, let's say y, and then this x, right? Y over x. The gradient is y over x, which means I can write y is fx plus h minus fx over dx is h. That's where this expression comes from. Okay. Actually, there's another expressions, but it is the same conclusion. But I prefer this one. It's easier to understand. And then when he moved B to A, he makes the distance getting closer to 0, right? And Newton, he want to have tools to communicate. Okay, how to communicate that this point is getting closer, and that's why he developed limit. It's actually tools to help us getting closer to one point. Okay. So that's limit. So limit So this is the first principle of derivative. So before you learn how to derive directly, like x squared derive 2x, it's easy, right? But before we learn that, or because we already learned before. So before we develop the dy over dx, the first introduction is this equations. So any functions you have, and you need to try to plug in, so change the x into other functions you want, and then solve the problem and input the h, you will get the derivative results. Okay? That's where it comes from. So we see this limit. So this means limit as h approaching 0. So limit is not really on specific point. It's close. There's like a small gap in between the limit calculations and the actual point. So we are never really touching the point, but we are close. But because we have established the tools limit, we just conclude, oh, that's the finite number, like before. Oh, it's just 2. If we calculate, it's not actually 2. It's 2,0,0,0,0,1 or 1.9999. Like for example, have you heard Zeno's paradox? Have you heard before Zeno paradox? No. Okay. So Zeno paradox is quite interesting. Okay. So you have okay, you have a person here, okay, and you have a wall here, wall. Okay. Let's say the distance between the person is 1 meter. Okay. Zeno paradox said that the person will not touch the wall because every time, or maybe here, it will be easier. So the rule, okay, for the person to go here, he can only goes half, and the next time he goes half from the previous distance. Okay, so if this is 1 meter, so he goes to here, from here goes half here. Okay, so after half, he can go half from previous distance. So go here 1/4, and from 1/4 he goes half from before. Can he touch the wall? Can he touch the wall? From the rule, it's not, right? But from limit perspective, he can. Okay, got my point? That's limit. So it's like you want to reach maybe someone you like, but you cannot even reach her or him. You cannot. Okay, it's like that. Okay, but hopefully it's not you. Okay. So that's Zeno paradox. Okay, we can approach this. Okay, if you remember the so you can see that this is like half plus 4 plus, right? It's like a series, and it has a ratio half, right? If you remember, but we will discuss this, I think, in the next semester. But don't worry. I think you already know the formula. The final formula is actually the S, right? So let's say it start from half, and then the ratio is half. So actually it's 1. So it's reached the wall. This is including limit Sn getting infinity. So this is limit problem. This is actual limit problem. But don't worry, this is the sequence series for the next semester. But it's just to show you how limit works. Okay. Another thing, this is not too important, the same before. I just want to show you the idea. Oh, this is also important. So let's say you have a distance. This is for 50 meter. You have ball here. It's drop, just like Newton did. So ball drop. Need to find velocity of the ball after 5 seconds. Okay, if you get this information, can you solve it? What do you think you need? Okay, I will give you the thing you need. Okay, so you have the position. This is developed by from Galileo Galilei. So he established models that when ball drop is actually the position functions is 4.9 t squared. Okay. The question is, can you find the velocity of the ball after 5 seconds? After 5 seconds, right after 5 seconds, what is the velocity? Or if you want to skip uh, the whole process, you just need to derive, right? In physics, you just to derive. But I want to show you how the logic, okay, how the logic process. So because there is no uh, interval time, right? You need to be exactly uh, knowing the time. Okay, what's the interval? Okay, the t0 from t0 to where? But the question is t5, right? So we need to make our own interval. So imagine we have t5 to, let's say, t 5.1. Okay, so velocity or average velocity is a change in position and time elapsed. This is exactly, just plug in the functions. So we just use the functions 4.9. The squared, the change position is from 5.1 to 5. Okay. And then the time elapsed is 0.1. Okay. You don't need to calculate. I will give you the answer. This is actually 49.49. Okay. And the same way, you develop another interval from 5, or maybe easier to have a notation. Let me write notation. So from 5, before it's 5.1. Okay, this is 4949. Okay, and this actually become 0.49, and then the next number is become 0.049. And when you get like closer, like to 5, you get more zero to come. Okay, and eventually, conclusion, it will get, as t closer to 5, average velocity closer to 49. Okay. Okay. This is what you call, maybe in also physics, this is you call instantaneous velocity. So what does it mean is the velocity at that time precise. Okay. So when you drop the ball after 5 seconds, that is the precise time or precise velocity. Okay. So basically, this is just the logic that to have you understand the subject. Okay. So how you are going to find the instantaneous velocity? Basically, you just need to derive. You already know the derivatives. You just need to derive. But how exactly it's happened, like from time interval in limit perspective. So this is what's happened. Okay. And that is why you have derivatives in your answer. Okay. Okay, get it? Okay. Okay, another thing, as a introductory concept. Okay. This is triangle, right? What is the area of triangle? Usually you have height. What do you call in here? Base or what? Usually is the symbol. But you know height, base, and half, right? The area. Uh, yeah, just make it this one. Okay, area of triangle is half of H and B. What if, okay, you want to know the area of circle based on triangle? Can you make some models or some approach? So from triangle, not this triangle, maybe triangle from here, can you develop area of circle? So you don't know area of circle. Okay, pretend you are not knowing any area of circle. How you are going to approach this triangle to get the area of circle? Area of circle is just PR squared, right? It's the maybe the easiest geometry that you have ever learned. It's, aside from rectangle, triangle, and circle is like the basic shape that you learn in math. Okay, can you find or can you prove from to get the area of circle from the area of triangle? Can you do that? So the idea is, what I mean is, you have this first. Okay. So this is one triangle. You can make any triangle, any polygon. Okay, any polygon. So this is polygon, polygon with n is 3. Okay, you can increase the n. Okay. So if this is the case, let's say so this is H, this is R. Okay. Okay. So if you see this polygon with n equal 3, you'll notice that it has the missing area here that you won't be able to calculate if you want to calculate whole circle. Okay. So the idea is make a circle. You try to increase the polygon. So increase the n. Okay. Let me check the. Okay. So increase the n. So this is 1, 2, 3, 4, 5, 6, 7. Let's make it 8. So if you see here, okay, I have a lot of triangle here. Okay. Okay, so this is actually should be here. Yeah, but yeah, you know that. and you have the height is in the middle, and this is r. Okay. What happens if I'm increasing the n? So n is, this is 8. If I'm increasing the number of the side of the polygons, can it reach the circle? I think almost reaching the circle, like really infinitely small amount. You can do that. So area of triangle, okay, is half. Let's say this is A, B, this is O. The center is O. So half AB and H, and then calculating on how many triangle, right? Let's say N. N is the number of the triangle. So area of the total triangle. Okay. And AB, the side of the polygon, if you multiply by all sides, it will become the perimeter, right? The perimeter is the perimeter of the polygon. Okay, so when H when H, so when N is larger, so N larger and larger. So when you increase the N, so it's 8, and then maybe increase, the side will be smaller, and this height will approaching the radius, right? So see here, this is the height, right? When you increase the number of this side, this height will be reaching almost here, almost reaching the radius of the circle, right? So H is closer to R, okay? So your formula from this ABN become the perimeter, become the circumference of the circle. This become 2PR, and H become R. So you get the PR squared. Okay. So that's how the how to say that, how they got the pi. It's actually the circumference over diameter. Okay. So from this part, what I want to take approach is this is also limit. Okay? This is also limit. So H closer to R, you need to get N larger and make the H closer to R, okay, by infinitely small amount. And you will get a geometrical perspective on finding the PR squared. Okay? That's also limit. Okay, got the idea? Okay. Okay, so that's all the idea of the limit. Okay, so now we are going to the limit of the functions. So this is all introductory of limit and how limit is actually making some of our works easier. Okay? The same way from this triangle, the first person to calculate um, the diameter of Earth. Actually, they are doing similar thing with So they go to the peak of a mountain. They imagine how tall the mountain is, making like a triangle, and then try to approach the circle also. Okay, now we skip this. Okay, so this is limit of function. Okay, the functions here is x minus 1, okay, so let's see. Okay, what does it mean is we are trying to find this but before we solve all the functions, we need to take a look at the graph. Okay, so x equal 1 is here, right? So in limit, okay, if you set some number as your approach, like for example, the value x near the x equal 1. So in this 1 here, the point 1 here, you can do approaching this 1 from left and approaching from right. Okay? You can do both. Okay, like previous, I told you before, you can approach from left, from right. Okay, so you can approach from here. You can approach from here, from left, from right. And actually, this will also make a difference in the functions from here, from up and down here, from the functions. Depends on how you approach these, number 1. Okay, so if you think carefully, okay, what is happening when you are put 1 here? If you put 1 and then make a calculation, you see it's become this part. Okay? We call this part in calculus indeterminate form. I will tell you later in indeterminate form. So indeterminate form is actually not really defined. What is this? Okay, and you can try, maybe if you get your calculator, you have graph calculator, or maybe you open some website and try to graph these functions. You'll get, and there's nothing wrong here. It seems nothing wrong here. But because usually the website, they are using the real scale, and the graphing calculator usually also using a real scale. So you will not see any difference here. But if we take a look closer, you will see that it's actually like this. There's something here, something that makes the graph is broken there. It's discontinuous. It seems that it has like hole, right? But again, okay, like I said before, you may have hole in your functions, but if you approach, for example, you approach from right, maybe 1.000001, we'll get actually nearby this 0.5, right? You approach from left, maybe 0.99999, maybe you get 0.4999999, right? It's getting closer to 0.5. So according to our theorem, as we mentioned before in like how Newton did and etc., we have limit. So the limit is there, but the function is not defined there. Okay. So the limit as x approach any a number of f of x, you can say the limit has limit. But maybe when you are putting a there, it's not defined. But still you have the number, the limit. Okay. Okay, so that is actually pretty important in limit. Okay. So you may have limit, but you may not have the point there. Okay. So actually this is undefined. So this as x getting closer to 1, fx getting closer to 0.5. Okay, let me write in new notes to make it more clearer. Okay, I will write the same thing. So definition, so limit. So f define when okay, x is near the number a at some let's say open interval. Except maybe at a itself. So a is this a. Okay? So that's meaning except maybe at a itself. So maybe the a is not defined at the a. Okay? But close that a, we can see it's getting closer to some value. That's why it has limit, but it's not defined on that x. Okay. Okay. In some situations, okay, it can be like wait a minute, like this. Okay. So the first one is pretty normal. There's nothing wrong about that. It's normal. Number two here, number B, there is a hole here. So there is a removable point or hole if you want. But still, you can find the limit. Okay? You can find the limit, even though there is a hole. Okay? And also here, it has defined here. But remember, okay, even though you have some definition here, okay, for your A, your limit is always nearby this A. It's not on the A. So this is also having a limit. Okay? You approach from here, it's actually approaching this L. So it has limit. Even though you find at A itself, maybe it has a different value. Okay? It can also happen, but it also has limit. So all having limit.